For section 5.3, we're identifying whether models of data are linear, exponential, or quadratic. So we're going to look at each one separately, and then when you're doing your assignment, you're determining which of the three it is. It could also be neither of the three models. So how can we determine data in a table is modeled by a linear function? And so we do that by looking at the first differences. So the first difference means the value that is the difference between two consecutive y values. So technically, if I'm finding the first difference between the first set of y values, I actually have an extra box here. I'm not going to fill that one in. I'm taking the second y value, which is 1, and I'm subtracting the first y value from that, which is -1. So if I were to do 1 minus -1, that gives me 2. So that's really 1 plus -1. And so that's the value that I would add to get the next point. So if I take -1, I would add 2 to -1 to get 1. So this should follow. So if I add 2 to get that, I should be able to add 2 to get 3. I should be able to add 2 to get 5. I should be able to add 2 to get 7. And so notice that it worked. Okay, so if I ever kind of get stuck and I'm not sure if it's right, what I can do is do that subtraction. So to find this difference, I would do 3 minus 1. And again, that's that value for 2. Then I would do 5 minus 3, and that gives me 2. And then last, I can do 7 minus 5, and that gives me also 2. Okay, so to find those first differences, I'm taking the difference in the y value minus the one before it. Okay, so let's look at quadratic. So quadratic is similar, it's just second differences. So this one actually has an extra box in the same way, and that means it's going to end up with an extra box here. Okay, so we aren't going to fill those in. So remember, strategically, what I'm doing is I'm taking the number, the y value, and I'm subtracting the previous y value. So 9 minus 3 gives me 6. So if this is linear data, I would add 6 to get the next value. But if I think about that, 9 plus 6 is not 19. Okay, it's actually, if we look at that, plus 10, right? I would add 10 to 9 to make 19. Again, I can get that value by taking 19 and subtracting the previous number 9 from that. So that's where I'm getting the 10. As it gets bigger, maybe it's more difficult to find those values. So again, I can take 33, which is my next value, 33, and I can subtract 19 from that. And if I do that, that gives me 14. So I'm adding 14 to get the next value. My first difference is 14. And then I have 33 to 51. So if I take my 51, I'm trying to find the difference between that and 33, and I subtract 33, that actually gives me 18. So I'm adding 18 to 33 to make 51. So now, because these were not constant, what I want to look at is the second difference. So the first difference was not constant, so it is not linear. Okay, if the second difference is constant, that's what's telling me that it would be quadratic. Okay, so constant second difference tells me that it's quadratic. I didn't highlight this before. A constant first difference tells me that it's linear. So because all of these were the same value, it's a linear function. Okay, so I have to do the same thing now, but looking at these numbers. So from 6 to 10, if I think about that, to go from 6 to 10, I'm adding 4. To go from 10 to 14, aren't I also adding 4? And then to go from 14 to 18, I'm adding 4. So again, I can do that by subtracting. So 10 minus 6. 10 minus 6 is where I get the 4. Here, 14 minus 10 is where I get the 4. And then 18 minus 14 is where I get the 4. So that tells me that since all of these values are plus 4, that this is a quadratic function. Okay, so I'm looking at those differences to determine what type. The last type of function is exponential. So in an exponential function, I'm not going to have constant first differences or second differences. Okay, but I should have a constant ratio. Okay, so my first difference, I'm looking at my y values and determining what I add to get the next one. So 1 plus 1 is going to give me 2. 2 plus 2 is going to give me 4. 4 plus 4 is going to give me 8. And then 8 plus 8 is going to give me 16. Okay, so I see those are my first differences. This is not linear. Okay, those are not constant. So then if I look at the difference between these values, so to go from 1 to 2, I'm adding 1 again. Then to go from 2 to 4, I'm adding 2. And then to go from 4 to 8, I'm adding 4. One of my clues to myself to tell me that something is exponential is notice that the first difference is really just that y value. The second difference is also just the y values. So we will kind of sometimes see this repeated pattern. It depends on which part of a table we're given or if there's a translation. But in general, if you see that where the first difference is the same as the y values, it likely means it's going to be exponential. So you should look at the ratio. Okay, so my first difference was not constant. My second difference was not constant. If my ratio of my y values, it's constant, I should have an exponential function. So instead of thinking about what am I adding to get the next y value, I'm thinking about what am I multiplying by to get the next y value. So 1 times what makes 2. And the way that I can do that is by dividing consecutive y values. So I'm looking at 2. So I'm going to divide 2 by the previous y value of 1. That's a 2. So I should multiply by 2 to get each y value. Okay, so if I look at this one, 4 divided by 2, notice that's also 2. So 2 times 2 is going to give me 4. 4 times 2 is going to give me 8. 8 times 2 is going to give me 16. Okay, so notice that we've got constant, ratio, it's all 2. So that means that it's exponential. Again, if I actually do the ratio, like sometimes if it's a fraction, it makes it more complicated. I would do 8 divided by 4. That's how I got the 2. And then 16 divided by 8. Okay, so constant first difference would be linear. Constant second difference is quadratic. And then a constant ratio is exponential. If it's anything besides those 3, that means that it's not those types of functions.